isn't anything new. It's just applying the sine, cosine, or tangent, depending on which one we need, to word problems. That's why this is really only just 1 page in length. But we do have 2 vocabulary words. One is angle of elevation, and the other one is angle of depression. So the angle of elevation is just kind of like, here, let's say you're standing here, here's this house, and you're looking to the top of a cliff or mountain or whatever. The angle of elevation is the angle of your line of sight. Okay, so imagine if you were to have like a string tied from here to here, it's the angle it makes with the flat land, with the horizon. Does that make sense? So it's the angle between line of sight when an observer looks upward. So right here, that's your angle of elevation. It's just, okay, you can also think of, we're going to do an example here. A pilot is flying at 10,000 feet and wants to take the plane up to 20,000 feet over the next 50 miles. What should his angle of elevation be to the nearest 10? Okay, so just imagine, right? Okay, so here's the plane. Sorry, I can't draw a plane. And you want to fly up. So like imagine right here at level, this is at 10,000, and we want to get up here to 20,000 feet over 50 miles. Now, one thing you should notice, these are not the same units. So we either have to change the 50 miles to feet or the feet to miles. And if this is 50 miles, and this is, so let's say it's starting out at 10,000 and you want to go up to 20,000 feet, really what's the distance that we're increasing? 10,000, right? So this actual length is 10,000 feet. Does that make sense? No. Well, it's starting. Okay, we're taking an airplane that's already in the air. The airplane is already at 10,000 feet. It wants to go up to 20,000 feet. Okay, which one did we want to change? The miles to feet or feet to miles? Okay, so anybody recall how many feet are in a mile?
52, yeah.
Good. So we're going to take 50 times, usually learn it middle school.
My dad and I were having an argument about a mile. He's like, it's 3,700.
5,280. So we're going to take 50 times 5,280, and we get 264,000. It doesn't matter. And now that's going to be feet. Now, I'm going to introduce a new letter. It's kind of looks like a circle with a line through it. This is a Greek letter, theta. Theta is a letter that is usually represents an angle measure. Now, we could have used x. I just wanted to introduce theta so that you kind of get used to it because you'll be using that a lot in Algebra 2. It's just theta. X could be anything. X could be the length of the side. Usually if I'm solving for an angle measure, we like to use theta. Now, I want to go back to SOHCAHTOA. Sine, cosine, or tangent. In relation to this angle theta, what do I want to use? So which one's going to match? Sine, cosine, or tangent? Well, I have the opposite side, and I have the adjacent side. I don't know the hypotenuse. Now, could I use Pythagorean theorem and find the hypotenuse?
Yes.
So technically, I could use any one of the three, but because I have the opposite and adjacent, I'm going to use tangent. So I'm going to write tangent of theta equals, what do we put in the numerator? 10,000. And the denominator, 264,000. And then we have to do something in order to solve for the angle measure. I want to basically move that tangent to the other side, and when I do that, it becomes tangent inverse. Do you remember that? I know it's been a while. Yeah, you can do that too. So what do you want to make it, 10 over 264? Okay. Oops, wrong calculator. So we have tangent inverse of 10 over 264. So we get about 2.2 degrees, which seems kind of small. However, do we really want an airplane to have an angle of elevation of 80 degrees or even 15 degrees? No. No, a 2-degree angle of elevation is okay. 3 degrees, 4 degrees, but with an airplane, we don't want it to be really large. So it makes sense that it's small. Yeah, that would be a nightmare. Okay, angle of depression is the same idea, but instead of looking up, we're looking down. That's all. Okay? And actually, the angle of depression and angle of elevation happen to be congruent angles. Why? Well, they're a special type of angle. Alternate interior. Because technically these two lines would be parallel to each other. So just keep that in mind. So angle of depression is the other one. And that's when you look downward. Okay, here we have a tailgate of a moving van. It's 3.5 feet above the ground. And then a loading ramp is attached to the rear of the van at an incline of 10 degrees. So you'll see the battery's running low. I'll have to move over here so I can keep it plugged in. So what did I just say? These two angles were congruent here and here. So this is 10 degrees. So now I can kind of look at this being my right triangle. And I want to know the length of the ramp. So what am I looking for? Am I looking for this or this? I'm looking for the ramp, which is the hypotenuse, right? So I'm going to label this as X. And now we go back to SOHCAHTOA. Which one do we want to use, sine, cosine, or tangent? Well, in relation to that angle, we have opposite is 3.5, and the hypotenuse is what we're looking for. So it's got to be the first one. So we're going to write sine of 10 degrees equals 3.5 over x. Now I want to solve for x, so I'm going to multiply both sides by x. And then I want to divide by the sine of 10, because remember we're isolating dx. So we're going to type in 3.5. Go ahead and do that. 3.5 divided by the sine of 10.
Is this supposed to keep just like turning off?
You can change the settings. Okay, so your calculator, you can change the brightness. It's just like your laptop computer, right?
Like when it's auto.
You can go into the settings and you can change how long you want it to stay on before it goes off. Like if you want it to stay on for 10 minutes instead of 1, you can go into the settings. If you want to have a brighter screen, just know, just like your computer, if you keep it, from going to sleep and you keep the screen bright, that's going to drain the battery more. That's all. Because we're not looking for the angle measure. So when we're looking for the angle measure, that's when you use the sine inverse, the cosine inverse, or the tangent inverse. But I know the angle measure. That's 10 degrees. So I'm never going, when I know the angle measure, I'm never going to use that little -1 trig function. Okay? It's only when I'm looking for the angle measure. What did anybody get?
20.2.
20.2. And what are the units here, since this is a word problem?
Feet.
Feet. So the ramp is 20.2 feet. So again, nothing, that actually was a good review for the SOHCAHTOA part, because there was nothing new, just how we would apply it. There are 2 parts. We're only going to do part 1 of 8.6 today, and then we'll do the second part. So we have something called the law of sines. And so, guys, everything okay over there?
Sure.
Sure?
Yeah, sure.
Calculator working?
No, that's why I wasn't sure. I'm using Benny's, which is somehow.
Would you like to borrow a calculator?
I'm borrowing Benny. Currently.
Oh, okay.
It's here. It's amazing.
Excellent. Okay.
If you didn't got not stealing it.
All right. Take a look at this triangle. Basically, in order to use sine, cosine, and tangent, you need to have a right triangle. So what I'm going to do is I'm just going to look at, for the sine of A, just look at triangle ABC for right now. Kind of ignore that little triangle on the right. So this one. Okay. What would be the sine of A in that case? It would be opposite, which would be? Wouldn't this be the opposite and this be the hypotenuse? So it would be H over B. Do you see that? I'm just looking at the left part of the triangle because we need a right triangle. We don't know for sure if right here this is a right angle. Are we okay with that? All right. Now, look at this triangle here. And now, what would be the sine of B? So it would be H over A. Good? Now, how could I set this up to solve? Well, we have H in both equations. So what I would like you to do, let's isolate H here. So I'm going to multiply both sides by B. So I have B times the sine of A is equal to H. And then do the same thing over here. So I'm going to multiply both sides by A. So A times the sine of B is equal to H. So B times the sine of A is equal to A times the sine of B. Okay, I'm just basically using substitution. Right? If both of these are equal to H, then that means they have to be equal to each other. Which actually results in this proportion. So in other words, if I take both sides and I divide by A and B, I would get this proportion. Now, why is this significant? This is significant because I no longer need a right triangle. If I have any triangle, I can find the measures of the sides. With SOHCAHTOA, which is basic sine, cosine, and tangent, you always need to be working with a right triangle. What makes this unique is that it can be the sides of any type of triangle. It could be obtuse, acute.
Why does SOHCAHTOA have to use it?
That's how it's defined. That's how they're defined by. So when they talk about a leg adjacent, if you go back to the initial definitions, you have to have a right triangle. What's that? Yeah, this is, well, basically, this is our theorem for law of sines. Now, yeah, and this can be extended to all 3 sides. Usually what we do is you pick 2 sides to work with and 2 angles to work with. You'll see. It's actually not a difficult theorem.
How'd you get to the?
Oh, I divided both sides by A and B. Do you see that? Honestly, don't worry about we basically proved the theorem. You don't need to worry about that. You just need to remember the sine of a certain angle opposite the side equals the sine of any other angle over its corresponding side, opposite side. Okay, all you need are two. There are some occasional situations where law of sines does not work, but you'll learn more about that in Algebra 2. I'll only give you ones that are going to work. Now, I didn't give you A, B, and C intentionally. I gave you different letters, E, P, and R. So let's go ahead and just label lowercase e, R, and P. And the directions are to solve the following triangle. You had some instructions previously when you were doing, I think, the trigonometry where it said to solve. That just means find all the missing angle measures and all the missing sides. So find all missing angles and sides. There's always going to be three things that are missing because you're always provided three things. You're either going to have two sides and an angle or two angles and a side. Okay. So here we have two of our angles. So what are the missing, what parts are we missing? We're missing angle R. We're missing side R, and we're missing side E. So I'm just going to write that on the side just so I remember. Those are the three parts that I'm looking for. Now, what's the easiest thing to solve for? Yeah, angle R. How do we find that? Well, three angles have to add up to 180. So go ahead and what do we get for that? 72. All right. So this is 72 degrees. Cool. All right, so here's how we're going to set it up. We want to identify one pair of angle and side that are opposite each other, or one angle and one side that are opposite. So here, I have this side and I have that angle. So we're going to start off with that as part of our proportion. So I'm going to write sine of 45 over 22. And what we want to do is we want to create a proportion to solve. Well, we can actually solve for E or R next. It doesn't matter. You just have to pick one to work with. Doesn't matter for you? R. All right. So then I want to use 72 degrees and little r. So I'm going to make that sine of 72 degrees over little r. You see what we're doing? So we're creating a proportion where it's the sine of an angle over the side opposite equals sine of another angle over the side opposite. And you just want to make sure, yeah. I mean, remember, where did it come from? It came from that proof that we did above. And so here what we want to do is just make sure you only have one variable. We do. Because sometimes you have too many variables and you might have to solve for something else. Well, now what do? We just cross multiply basically. Right? How do you solve a proportion? Now, you could type these into your calculator, but I want you to save that for the very end. So here I have r times sine of 45 equals 22 times the sine of 72. I want you to get in the habit of just solving it first. Just treat those signs like this is some number. We'll figure that out when we type it in. How do we isolate r now? How do we divide it by that whole thing, sine of 45 degrees. So now, so we just have to be careful when you type this into your calculator. What do we have? It was 22 times what? sine of 72. And then, actually, we can just put it in right away. Divided by 29.6. Okay. Is that degrees? No, because it's not an angle measure. It could be some other unit measure, inches, feet, we don't know. Okay. Now we're going to do the exact same thing, but we're going to set it up. Instead of solving for r, we're going to solve for e. So the first part, the sine of 45 degrees over 22, is going to look exactly the same. We always want to use an angle and a side that are directly opposite each other that we know. And then we're going to have sine of 63 degrees over e. And then same thing, right? We're just going to cross multiply like we did in the last one. So we have e times the sine of 45 equals 22 times the sine of 63. And just so you know, you don't actually have to put a multiplication sign in here. Also, on your calculator, if you just press 22 and then went right to the sign, it'll automatically interpret that like a multiplication, just like a variable. And then we're going to divide both sides by sine of 45. Right? What do we get? $27.7. Okay. That's basically law of sines. Okay. Now, do you think if you use law of sines with a right triangle, would that work?
Yeah.
It would. It would. It just wouldn't be the natural, like I would still refer to SOHCAHTOA if you had a right triangle. Okay, so solve the following triangle.
So SOHCAHTOA is only for right triangles.
SOHCAHTOA is for right triangles.
But
Law of sines is for anything.
Oh, wait, law of sines. Oh, okay.
Yeah, so notice when I draw this triangle, I'm going to put B, W, Y. I made it an acute triangle. Is it necessarily an acute triangle? I have no idea. Okay, we won't know until we set it up. We know angle Y is 66 degrees. We know angle W is 59 degrees. And we know little b is 77, so that means the side opposite angle B. So that means what are our three missing pieces? Okay, angle B, side W, and side Y. Okay, so we have to find angle B first, right? So how many degrees do we get for B? 55. Because I need to always make sure, in order to use law of sines, I always have to make sure that I have a side and an angle directly opposite each other. Otherwise, if you don't have a side and an angle directly opposite, you can't use law of sines. Okay, so we have sine of 55 over 77 equals, so here it doesn't matter. Do you want to solve for W or Y? Doesn't matter which one we do first. W. Okay, so sine of 59 over W. Just remember, you can never find the third side by using Pythagorean theorem. Why not? Because it's not a right triangle. Exactly. So that's why we always have to go back to the law of sines a second time. Okay, so what do we get for W? W is going to be 77 times the sine of 59 over sine of 55.
What did you like skip?
Oh, I skipped a step. Did you follow that? But see, look, it's always gonna be when the variable's on the bottom. So it's gonna be this times this.
No, yeah.
Divided by
I
20.
just like.
If you show, yeah, you can go right to the answer if you want, or if you want to show that extra step, that's fine. Did we get 80.6? Okay. And then the last one, we have sine of 55 over 77 again, but this time it's sine of 66 over y. Put my degree signs in there. All right, plug that in. Also notice, if you look at your angle measures, these are all relatively close in degree measure. So the sides should also be pretty close in measure. You shouldn't get something like 10. 10 wouldn't make sense. Any question? What do you guys get for y? 85.9. Are you just going to go with that? Oh, why, there's no degrees. And then also just another way to double check some of your answers, right? If this is 85.9, which is y, that should be across the largest angle. Remember some of those other theorems, like the largest angle is always opposite the largest side and so on. Okay, I think this is the last one, right? Okay, solve triangle XYZ. So again, we don't know what kind of triangle. So often we'll just kind of draw it out, label the opposite sides with the lowercase letters, and then label what we have. So we know y is 17, that's side y. Z is 14, and the measure of angle y is 92. So actually this is an acute, or an obtuse triangle. Okay, so the three things that I'm missing are, I'm missing angle x, I'm missing side x, and I'm missing angle z. So first I want to identify the angle and side that I know that are opposite each other. Right, so 92 and 17. So I'm going to do sine of 92 over 17 equals, well, I don't have enough information to find angle x or side x, so I got to do z. Problem is, z is actually the thing that I'm missing. I'm missing the angle measure, which is fine. We'll do sine of z over 14. Don't forget, we still have to take sine of the angle. Now this is going to be a little bit different than the last one. Remember what I said, whenever we're trying to find the angle measure, that's where you need the little -1, okay? But first thing you want to do is isolate sine of z. So let's just cross multiply. We get 17 sine z equals 14 times the sine of 92. And then what? We want to divide both sides by 17. So I have sine of z okay, so far I just cross multiplied. How do I solve for z? I want to take the sine inverse of the right side. So z is equal to sine inverse of this whole thing. Okay, so that just takes a little bit of calculation. And I would recommend just typing it all in at once. So sine inverse of 14, what was it? Sine, oops, I have one too many. I didn't say that on purpose, that's funny.
Wait, I don't understand how you just said that. Wait, what did you do?
Okay. Did you do the sine inverse?
Why do you do the sine inverse of the entire thing?
Because we're finding the angle measure. Look, another way that you could do this is figure out what decimal this is equal to, and then take the sine inverse. You know what I mean?
I didn't see that you divided by. Did you get 55.4?
Yes, 55.4. Finding an angle measure is a little bit more complicated. And that's degrees. So we'll put that in here, 55.4 degrees. Okay, now, once we know Z is 55.4 degrees, can we find angle X? Yeah, so just take 180 minus 55.4 minus 92, we get 32.6 degrees. And now we could set this up, sine of 92 over 17 equals sine of 32.6 degrees over side X. It's always easier when you're trying to find a side, but so here we have 17 sine of 32.6 divided by sine of 92. So take a minute. So probably what we'll plan on, although I know probably you're not thrilled about this, tomorrow we'll do the rest of 8.6, and then Thursday will be our review, and then Monday will be our test. I know Monday's not always a fun day to have a test, but I can't push it back more than Monday. That should work. Did you guys get an answer for this one? 9.2? Okay.